So we can get started. Uh, let's see. Hello, everyone. If you don't remember me, or if you haven't met me yet, my name is Kingsley Nawasu. I'll be your instructor for this advanced Python programming course. I see we got some familiar faces in here. So you guys should know how I operate and stuff. Um, so yeah, I suppose we can just get started now. Let me share my screen. Yeah, we can tell how comfortable we all got with each other. See, because now I'm teaching classes from my bed. All right. Now, before we get into the lecture, we'll just do a quick little review on Python since it's been a while since the last class. Let's see. Can you guys hear me all right? Okay, good.
Yeah.
All right. So let's see, review. We learned code block and code flow. Those are very important basic skills for any development work. Let's do an exercise to brush up on this stuff. So we have here a dictionary. Now, can somebody tell me what the keys to this dictionary is? This dictionary called addict. Right. So if you can remember, the keys to this dictionary is name, age, and school. Those are the keys. Now, given the keys, can somebody tell me what the values of this dictionary are? All right. The values are going to be Zara, Seven, and Mandy. So those are the keys and values of this dictionary. Now, since we have that, our objective is to write code that could print out the values one by one. So the values to be already said is Zara, Seven, and Mandy, ES. Um, does anyone have any ideas on how we can write code to print out the values one by one? If not, that's okay, because we'll go over it together. All right, let's do this together. Oh, I need to. So we have this dictionary called addict. Now we can print out all the values of this dictionary using a for loop. So if we can remember, a for loop is something like for I in addict, which is a dictionary, you can print addict I. So this syntax for I in addict is going to iterate through or go through or loop through really all the keys in this dictionary. So name, age, and school. And we can print out the values by just doing addict and then brackets I. That way we'll get the values. So if we run this code, we get Zara, Seven, and Mandy ES. So that's our little Python review. Does anyone have any questions? All right. So the topic of this lecture is going to be on exception handling. So what is exception handling? We'll go over that today. Uh, So let's try out these code. When you are asked to print and when you are asked to input an integer, please try to input characters to see what happens. Y is equal to int input. Please enter an integer, print y. So let's run this code and see what we get. All right. So I just ran this. So I just started to run this code. And now we're asking for an input. Please enter an integer. If I put in 100, we print out 100, which makes sense. Now, what do you guys think will happen if I put in howdy? Will I get, well, how will Python handle it? Because it's asking for an integer, but I'm putting in a string. What do you guys think is going to happen?
Is it gonna what?
Yeah, what do you think, Audrey?
Error.
Yep, it'll give an error. So let's confirm that. Yep. Uh, and I think that you were headed in the right direction too, Henry. So if yeah, Audrey, do you have something to say?
Well, technically an integer is a whole number, so what would happen if you entered in a decimal?
Let's see. Let's put in 6.453 4521. Oh, I get an error too. Yeah. So I'm getting an error when I put in a string or an integer, or a string or a decimal, which makes sense. You get value error, invalid literal for int with base 10, pretty much saying that this is a float when when the Python is expecting an integer. All right. So we ran into an error and the system stops executing the code. So that's what happens when we try to put something that's not an integer into Y. Another example. So let's run this code and see what happens. Hmm, interesting. All right. What do you guys think will happen if I try to run this code? There's something in this list that will cause a problem. Did you just raise your hand, Audrey? All right. Let's look at what happens when we iterate through this loop, iterate through this list, and we get to 0. What is 10 divided by 0? Yes, Henry?
0.
Let's see. Yes, Audrey?
Uh, and divide by 0, you can't divide anything by 0.
And
I
Python
can't
is,
hear
oh, can you hear me?
I can't hear you.
Can you guys hear me now? Oh, okay, I don't know what happened. Well, yeah, I was just saying that you were correct, Audrey. Good job. So we cannot divide anything by 0. And Python was able to catch that too because it's complaining that we have a 0 division error, division by 0. So it was able to print out everything up until we got to 0. So it did 10 divided by 1, 10 divided by 4, 10 divided by 8, by 5, but then it got to 0 and it and it errored out. So that's what happens when we try to run this code. So a runtime error, which is the errors that we've been seeing, will suspend the execution of your code. So one thing that we can, oh, so one thing we can try to do is put a try except statement in your code to trap errors. We'll see what that means in a second. So let's copy this and see what happens. So we have while true, and then we have this try. So we have this try except block. So we're going to try this code block here, and then we're going to try to trap an exception with this except block here, except value error. And if our error is a value error, we're going to print out, oops, that was not a valid number, try again. So if we were to try to run this code, we'll enter a number, let's say 10, it works fine. But if we were to try to run, to put in 6.4564532, we'll get, oops, that's not a valid number, try again. And then we try and then we start over from because of the while loop. So if we were to put howdy, we'll get another error. But if we put 8, then that's it. And then we break out of the loop. So can anyone tell me what the advantages of a try except block is from what we've seen?
So that instead of just giving us an error code, then we get like something telling us it's wrong.
Yeah, exactly. Yeah, so before we had the try except block, when when our program got a bad input or when it got an error, the entire program would just stop. But now with the try except block, we can continue going when we get an error, which is great. So as we've seen, this will trap the runtime error when the system tries to cast a string to a number. So the try statement works as follows. First, the try clause, the statement between the try and except keywords is executed. If no exception occurs, the except clause is skipped and the execution of the try statement is finished, which is what we expect. So as we saw earlier, in the first, what is in the try block is executed. And then if there's an error, then we go down here in the except block. That's how try except statements work. So if an exception occurs during execution of the try clause, the rest of the clause is skipped. Then if its type matches the exception named after the except keyword, the except clause is executed, and then execution continues after the try statement. So what that paragraph pretty much means is that um, whatever is in the try block is executed first, and if there's an error, it's just going to immediately go to what kind of error is in the except block here. So if it's a value error, then we'll print out this stuff down here. We'll execute the stuff here. Yeah. If an exception occurs which does not match the exception named in the except clause, it is passed on to outer try statements. If no handler is found, it is an unhandled exception and execution stops with the message as shown above. Um, so what that pretty much means is that if there is no matching error here in the except block, then the program will just fail like normal. So let's see if I can try to think of another way to get an error that is not a value error. Um, like Control C? No, that didn't work. Uh, yeah, I'm not sure. I think a value error is all I can really do right now. But anyway, yeah, it's sometimes possible for a program to output more than one type of error. So you'll need an accept clause for each type of error. Um, and if one doesn't match the error that is like in the error that I mean the kind of error that was produced in the try block, then the whole program will just fail like normal. That's what this second program is trying to say. So a try statement may have more than one except clause, and I'm sure we'll be seeing examples of that as we go. To specify handlers for different exceptions, at most one handler will be executed. Handlers will only handle exceptions that occur in the corresponding try clause, not in other handlers of the same try statement. An except clause may name multiple exceptions as a parent, parenthesized tuple. For example, and then we have all this and then pass. So what does this slide mean? So in our example here, we just have one except block, but it's possible to have other except blocks too. Like, oh geez, wait, hold on. Uh, so it's possible to have other except blocks like except name error and then stuff, and then we could have except uh IO error and then pass. So it's totally possible to have more than one except block in any given try statement. That's what. Yes, Henry?
Wait, would this work like without PyCharm or like do you need it?
So if we try to do this in an interpreter like this, I'm not really sure how that would work. Uh, I guess you could, but it would look kind of messy. Hmm. Yeah, it would look kind of messy. So I guess for try except blocks, you would want to use an IDE like PyCharm or something so that it's because interpreters aren't really meant for that kind of stuff. I'm sure an interpreter could do it, it just wouldn't be pretty.
Okay.
Yep. All right. So it's possible to have multiple accept blocks in any given try block. Any questions so far about exception handling? Yep, idle Python works too. All right. The last except clause may omit the exception name to serve as a wildcard. Use this with extreme caution since it is easy to mask a real programming error in this way. It can also be used to print an error message and then re-raise the exception, allowing the caller to handle the exception as well. So what does that mean? That means that we can have something that looks like this, or we just have accept and then that's it. Will this work? Yeah, it does work. Yep, so we can just have um accept and this will just catch any other error that isn't already caught in the above except blocks. So this code block kind of gives an example of this of what we've been talking about for the last couple of slides. Let me just comment some stuff out. All right, so let's copy this. So in this code block, we have a try statement, we have accept IO error, we have an accept value error block, and we also have a wildcard accept block. Um, so yeah. So a question for you guys, can somebody tell me in what scenario that we would get down to this last accept block down here? This one down here. When would we get to this last accept block? We'll get here if the errors, if any of the errors above it aren't caught. So if our error is not an IO error and it is not a value error, then we'll get down to this last block down here. So let's try running this code. The okay. Was it giving an error? That's weird. Invalid syntax. There seems to be something wrong with this code block. Um, I'll just take a minute here to see if I can figure out why this is not working. Hmm. Don't know why this isn't working. I'll just have to remove this, I guess. Oh, okay. Oh, well, I guess I just won't run this. But yeah, if this code was working, what this would do is that it would try the code inside here, and then if it failed, it would go to this accept IO error, um, or it would go to the value error. And if none of those holds, it would go to the accept block down here. Wish I could run this, but it's not working, so I'll just comment that out. All right, next. Oh, one thing that I'll note, so at the end of this accept block, we have this raise keyword right here. What this pretty much means is that we'll send whatever error that this last accept block caught back to the function that called this try block pretty much. So we could think of raise as just sending an error back to the function that called this. So yeah. So built-in exceptions, there are many exceptions. You can create a new exception. All exceptions must be built on base exception. So let's take a look at some exceptions in the next slide. So these are some different kinds of exceptions. There's system exit, keyboard interrupt, generator exit, a bunch of different exits. Um, exceptions. And you guys could take a look at this with this link that's provided to see more details on exceptions. So this page will explain what each one means. Somewhere in here, I guess. Yeah, right here. Yeah, so this page will explain what each exception means. Yeah, we have even more exceptions. As we can see, there are a lot of different types of exceptions. So the try except statement has an optional else clause, which when present must follow all except clauses. It is useful for code that must be executed if the try clause does not raise an exception. So what does this mean? It means that a try except statement can have an else, just like if statements can have an else. And we'll see an example of this. So we had this nice little chart that kind of outlines what can happen in a try statement. So we have try and then run this code and then execute this code when there is an exception or when there's an error. And then we have this else that's no exceptions, run this code. So that's how things flow in a try except block. A finally clause is always executed before leaving the try statement, whether an execution has occurred or not. When an exception has occurred in the try clause and has not been handled by an except clause, it is re-raised after the finally clause has been executed. The finally clause is also executed on the way out when any other clause of the try statement is left via break, continue, or return statement. So a lot of content there, but this next graph will kind of explain what that means. So this is what the finally clause does. So starting from the top, we have try, which is run this code, and then accept, execute this code when there is an exception, and then we have else, no exceptions, run this code, and then we have the finally block, which will always run the code regardless if there was an error or not. Right? So that's what the finally clause does. So now we have a little quiz. How many except statements can a try except block have? 1, 0, more than 0, or more than 1? Anyone have any ideas? Audrey?
D.
Yep, the correct answer is D. Good job, Audrey and Ivan. Yep, except statements can there can be more than one except statements in a try except block. Okay, we have another quiz. When is the finally block executed? When a specific Is it executed when a specific condition is satisfied, or when there is an exception in the try block, or C or D? When is the finally block statements executed? Audrey?
Always.
That is correct. The finally block statement is always executed. And we can see that from our little chart up here. When you have the finally block, we always run this code. Okay. All right. Let's see here. Uh, what is the output of the following code? So I'll let you guys take a look at this code for a bit, and then we could talk about uh, what the output of this is. So we have try, print try, except value ever, print value ever, finally, print finally. All right, let's see. All right, let's go through this example together. So the first thing that we're going to do is go into, yes, Audrey, do you have any?
Wouldn't the output depend on what the input is?
There actually is no input in this one. So all we're doing is just printing out. Yes, so I guess we could go through this together. So first we go into the try block and then we print try. Okay, so we know that for one thing that try is going to be printed out. And then we have an accept value error. Um, but since we're not really inputting anything, we won't go into this except block. And then we have this finally block. So remember that the finally block is always executed regardless if there's an error or not. So we're actually going to be executing um, uh, the print finally as well. So with that, we know that the answer is D. We're going to print try and then finally. Any questions about the quizzes? All right. So the raise statement allows the programmer to force a specified exception to occur even if there is no exception. So we have raise name error high there. What does that mean? It means that we can just raise an error, just so we can use raise to kind of create our own custom errors in Python. So let's copy this to see an example of raising an exception. So we have x is equal to 10. If x is greater than 5, then we raise an exception. Let's run this and see what we get. Yep, and then we get our raised exception. And see how our raised exception looks a lot like how a regular Python error would look like. It's in red and everything. Um, so yeah, this is an example of raising an exception, our own custom exception. So if you need to determine whether an exception was raised but don't intend to handle it, a simpler form of the raise statement allows you to re-raise the exception. What does that mean? Let's try out this code. So in this code block, we have try, raise, name error, high there, and then we catch our own error with accept name error, and then we print an exception flew by, and then we raise again. So let's see what happens when we run this code. So we get this stuff in the red here. We get this stuff in the red because we raised an error over here. We raised a name error in the try block. And then we caught our own error with this except block, and then we printed an exception flew by, and we see that down here. And then we just raise again, which means that we just send our error to the thing that called this function. As this slide explains it, uh, we we use the simpler form of the raise statement to re-raise the exception, which is what we did over here. Um, any questions about raising exceptions and our own and making our own custom exceptions? Right, let's move on. So we have an exercise, improve this code so the division can continue. Error message can be printed out when there is an error. So this is the same code that we saw earlier that gave an error when we tried to run when we tried to run it. So now we're going to try to use our new found knowledge to make an exception so that we can catch our error. So first, let's see what kind of error this thing outputs. So this code block, this code that I just pasted, outputs a zero division error. So what we're going to do is try to catch this exception. So the way we're going to try to catch this exception is that we're going to have this try, and then we're going to, so whoops. Yeah, we're going to have this try here, and then except. So what should I put for the thing that we're trying to catch in our except statement? I should put something in this right after the except here. All right, I'm going to need to put a zero division error. And this is what we're trying to catch. So we're going to print cannot divide by zero. So if we try to run, so what have we done? So we've added a try block to try to print out 10 divided by n. And then if we get a zero division error, we print out this thing can't divide by zero. So if we run this, we are able to get past our error that we were stuck on before. So this is an example of using a try except block. Yeah. Does anyone have any questions about this solution, about this exercise? Okay. My cat has been staring at me this entire time. No, come here, say hi. Say hi. There he is. He's been staring at me this entire time. All right, that's just my little cat. All right, let's see here. Thank you, Ivan. He is indeed cute. So, okay. So finally we have our homework. This homework is to improve the last homework. Please take a user input value, integer value 0 to 30 inclusive, and assign to x. Set variable y to value to 10. Check x value in your code. If x is less than y, loop n from 0 to x and print out n plus x within the loop. So yep, this part of the homework just, yes, Audrey?
What was the last homework?
Uh, yeah,
Wait,
it
what
was
was
from
our
the last.
homework? What was our last homework? Was that
Yeah, I think it's from the last class. So I think this slide was made assuming that we just picked up where we left off from the last class, but we can just pretend like there was no last homework. We really don't even need the last homework to do this. We could just follow the steps outlined here.
Wait, so how would we do the homework then?
Uh, so um, let's see.
So like for like what's X?
Yep. So for this homework, the first step is just to take a user input value, and you guys know how to do that. It's just using the input function. And then you're gonna assign that to x, and then you just assign a variable y to 10, and then you check the x value in your code. We don't really need the previous whatever homework that this slide is referencing to do that. Um, I think this first sentence here is just to try to jog people's memory, but we really don't need the previous homework in order to do this. this part of this homework really. So bottom line, we don't really need the last homework to do this. It's just, I guess the last homework that it's referencing um is it's just not really needed. So that answers the question. So we're going to assign a variable to x and y, and then we're going to check if x is less than y. If it is, then loop n from 0 to x, and then print out x plus n plus x within the loop. And then for the second part of the homework, if x is not less than y, loop n from y to x and print out n minus y within the loop. The user can type in anything. If it is not a number, please print out what the user has inputted, and also print out this is not a valid number. After that you ask the user to input a number again. So this should seem familiar from what we went over earlier today. Um, you'll need a while loop, and then you'll need a try block, and then also an except block to catch any errors. So this part of the homework is going to look pretty similar to what we have up here. It'll just be slightly modified. And then finally, this will go on until a user inputs a number. If the input is a number, then it works like it was in the last homework. Again, we don't really need the last homework that it's referencing. So with the tools that we learned today in class, you guys should be able to do this homework. Um, any questions about the homework? Yes, Audrey?
When is it due?
Let's say that it'll be due next Monday, before right before our next class. All right. And
Are you
remember,
gonna post it in the Google Classroom?
yep, it'll be on the Google Classroom. I'll post it in the Google Classroom. And remember, if you guys have any questions, post it in the Google Classroom or let me know. I'll be happy to answer them. Uh, and yeah. So we got yes, Audrey.
Like, how would you show your homework in the Google Classroom?
Um, there's some instructions on how to submit your homeworks. But so you could like post a screenshot of your code or post like the actual like code itself, like copy paste it into like a text box or something and submit that. I'm pretty flexible, so submit your homework in any way that you're comfortable. And you could always let me know if you have any troubles with submitting your homework. Okay. All right. Well, I suppose that's it for today. No one has any other questions. Do you have a question, Ivan?
No.
Okay. All right. Well, thank you guys for attending this first class of Advanced Python. Hope you guys learned something, and yeah, good luck with the homework.
Bye.